Hello all, Vinod here from Endurance Engineering Academy, and I'm back with one more question from GATE 2021. Okay, so GATE 2021 XC. Okay, so this is basically from XC B, that is fluid mechanics question. Okay, so and this question is based on flow over any immersed body. Okay, flow over a spherical ball or flow over a cylinder or something like that. It is a special topic. This topic is not there for mechanical. It is there only for engineering science. And we already covered this, in fact, in our XC test series. Okay, in our XC test series for GATE 2021. Okay, we had a similar type of question. Okay, similar type of question we have asked in XC test series for GATE 2021. Okay, so let us start the question. A spherical metal ball of density rho s. Okay, so they said that ball's density was rho s and diameter was d. They already mentioned it here. Okay, attached to a string is exposed to a cross flow of velocity u infinity. So this is the flow which is happening, as you could see that this is the flow, the fluid is flowing, and the velocity was u infinity, free stream velocity, and the fluid's density was rho f, and viscosity is mu. Due to the cross flow, the string makes an angle of inclination theta. So initially the string might be like this. Okay, initially the string might be like this, and now the cross flow is happening, and due to this cross flow only, the string is getting tilted. Okay, and it is getting tilted, and the angle of inclination from the horizontal was theta, as they mentioned here. Okay, and what else? With the top surface as shown. Okay, as shown here, the angle was theta with the top surface. The acceleration due to gravity is denoted by g, and for this flow, Reynolds number. Okay, so they given Reynolds number, which is very lesser than that of 1. And those who listen to my class, okay, that is in additional topic, I hope most of you guys know, those who subscribed for our channel. For GATE 2021 we launched a course called as additional topic course. Okay, so additional topic means all the topics which are in addition to ME syllabus. Okay, all the topics which are there in ME syllabus, in addition to that syllabus, what are the topics is there. Okay, in that topic course, I stressed this point. I think I stressed this point very clearly. Okay, that if Reynolds number was very less in case of flow over some bodies, okay, flow over any bodies, if the Reynolds number was very less, if it is very lesser than 1, then we can use a theorem or a law called as Stokes law. Okay, or Stokes theorem, whatever it is. Okay, and what actually it is indicating? It is indicating the drag force. Okay, the drag, there will be two types of forces, right? Drag force and a lift force. The drag force which is caused will be equal to 3 pi mu u into d. Okay, here u is the free stream velocity, d is the sphere. Okay, d is the sphere. The sphere on the fluid is going to flow over the sphere, right? So d is the diameter of the sphere, mu is the viscosity of the fluid, and u is the velocity, free stream velocity. 3 pi we know. Okay, so drag force, Fd is the drag force, 3 pi is fine, mu is the viscosity of the fluid which is flowing, u is the free stream velocity, d is the diameter of the sphere, okay, over which the fluid is flowing. This particular theorem can be applied if Reynolds number was very less. We cannot use this theorem for all the cases. Okay, we already know that. Okay, now they specifically mentioned that buoyancy force in the fluid is negligible. Okay, there are two possibilities in this question. It is somewhat straightforward. They said that buoyancy force is neglected, but if suppose they are asking us to consider buoyancy force, okay, then the question will vary a bit. Okay, how it varies I will say. Okay, first let us discuss this, how it varies we will see. Okay, the first point is they given lesser than, very lesser than or equal to 1, so I can apply Stokes law. Okay, simply I can use this formula for finding out drag force. The second point is buoyancy force is negligible. So buoyancy force is negligible compared to viscous force. So we will be neglecting the buoyancy force completely. We will be considering only viscous force. That is nothing but this drag force. Okay. Assuming the string to be weightless. Okay. They are saying that this string is weightless. See, they are not talking anything about the sphere. The sphere will have a weight. That is why they mention the density of the sphere. They are saying the string will be weightless. Okay. And offering negligible drag. So we don't need to consider the drag offered by this string also. Okay, due to the string, what are the drag which is caused, we can neglect it. Okay, now we need to find out what is this theta. See, this is really simple question if you know the basic concept. Okay, see, let us consider this is the sphere. Okay, this is the sphere. Now we need to draw free body diagram. Let us consider I'm cutting it here. Okay, I'm cutting it here and I'm drawing the free body diagram. So due to this string, there is going to be what? There is going to be a tension, right? A tension developed in the string, right? And what about the angle? Okay, let us talk about the angle later. There will be tension here. In addition to tension, what are all the other force which this sphere is subjected to? What are the other force? The force due to what is that? Due to this fluid, okay, due to this cross flow, that is nothing but drag force, and that drag force will be in a horizontal direction because the fluid is also flowing in horizontal direction, so there will be drag force. Okay, in addition to drag force, due to the weight of the spherical ball, okay, due to the weight of the spherical ball also, there will be what is that, due to spherical ball's weight, there will be, like, it will also act on the sphere. Okay, so these are the three different forces. Once if you drawn this, okay, once if you drawn this, then the problem is almost done. Okay, so for finding out theta, it becomes very simple for you. What you need to do, simply use the static equilibrium equation, summation of fx equal to 0, summation of fy is equal to 0. How to do that? Let me do it now. Okay, so the first, let me take this tension T. Okay, so tension T is acting like this. And what about the angle? Okay, what about the angle? They clearly mentioned that this angle is theta, right? So if I draw a line like this, what will be this angle? If I draw a line like this is theta. Let me erase it. This is theta, so this is 90 degree, so this is going to be 90 minus theta from very basic what is that, basic trigonometry. Okay, basic geometry or whatever. Okay, so this angle will be 90 minus theta. Now resolving this tension, I already made a video on how to resolve a force, right? So I already made a video, you can check it. So if I resolve in this direction, it's going to become, if this is 90 minus theta, what will be this? This is going to be theta, right? So if I resolve in this direction, it's going to become t sine theta. I already made a video on resolving of force, you can check that. Okay, and this is going to be t cos theta. Resolving of force, you can check it in basics. Okay, there is a playlist called as basics. In that basics, I already made it. If you already know that, not an issue. Okay, so t cos theta will be horizontal. Okay, t cos theta will be horizontal, t sin theta will be vertical. So now if I take a spherical ball here, totally weight, okay, weight of the spherical ball acting downwards, and tension, horizontal component of the tension t sin theta acting in this direction. In addition to that, there will be one more tension, right? T cos theta, vertical, sorry, t sin theta is vertical component, t cos theta is horizontal component of the tension, and in addition to that, drag force. Okay, in addition to that, drag force. Okay, now this is weight of the body. Okay, this is weight of the body, don't forget it. See, this is a case where we are neglecting the buoyancy force. Okay, here we are neglecting the buoyancy force. Buoyancy force is neglected, and that is what they are asking in this question. If suppose they ask us to consider the buoyancy force, what will happen? Let me write it. Okay, you consider the buoyancy force. If buoyancy force is considered, then there will be additional force FB. Okay, let me take, this is the sphere, weight of the body. Okay, weight of the body, tension, everything will remain same, t sine theta, and there will be t cos theta, and here also drag force, and one more force, that is buoyancy force, and that will always act vertical, in vertical direction, and always it act in the upward direction. So in gate 2021, this is the question which they asked. Okay, but there is a possibility for including the buoyancy force also. Okay, now coming for this question, gate 2021 question, summation of fx is equal to 0, which will clearly states that fd will be equal to t cos theta. Am I right? Simply fd minus t cos theta will be 0. So the force which is acting right side will be equal to the force which is acting left side. Simple. And what about summation of fy is equal to 0? Wb will be equal to t sine theta. Now this is 1, this is 2. Now divide 2 by 1. Okay, 2 by 1. So that will give me tan theta is equal to, Tt will get cancelled and this 2 will become Wb by Fd. Okay, now comes a mistake possibility. I could say that it is a mistake possibility. Even few students also did the similar mistake. Here, the density of the sphere is given as rho s. Okay, density of the sphere is given as rho s. Density of the fluid is given as rho f. So when I am finding out weight, okay, so if you had done a good amount of practice, you would have not done this mistake. But if the practice was not good before your exam, then you will do the mistake. I'm just highlighting it. This is weight of the body, right? Body's weight means I need to consider the sphere's density only. Okay, in general, we know weight is nothing but density g into volume. Okay, all these things has been already discussed in buoyancy chapter, or this is from basic only. We already know that. Okay, if I want to find weight of the body, then it should be density of the body g into volume of the body. Don't forget that. And drag force, as we know already, it's going to be 3 pi mu u into d. And why I am using Stokes law? Because Reynolds number is much lesser than that of 1. If it is not very small, I cannot use it. Keep it in mind. Okay. Right. Now, which will be equal to density of the body is given as rho s, that is spherical bars density g into volume. What's going to be the volume? 4 by 3 pi r cube. Here we will take diameter only, so d by 2 whole cube. Okay, 4 by 3 pi r cube, so that is d by 2 whole cube. The whole divided by 3 pi mu, and the given free stream velocity, u is the free stream velocity, right? In this case, the free stream velocity is given as u infinity. So let us take u as u infinity. Okay, let us take u as u infinity. And what about d? D will remain d only. So finally, rho as g into 4 by 3 yeah, into pi into d cube, and this will be 2 cube, that is 8 into 1 by all these terms, 3 pi mu u infinity into d. Now let me cancel all the things. What will happen? This is 1, this is 2. Okay, pi getting cancelled, and what else? This will become square. This is going to be 1. Okay, was there any other possibility? I think no, right? So what happens? 3 into 3, 2 into 3, that is 1 by 18. And in the numerator, it's going to be rho s g into d square. And in the denominator, it's going to be mu u infinity into, yeah, only mu u infinity. Was there anything else? Mu and u infinity. Yeah, I hope that's it. Fine. So this is going to be tan theta. Okay. So finally, what will be my theta? Tan inverse of, just I'm applying inverse on both sides, rho s g d square by 18 times mu u infinity. Let us check the option and find out which one is correct. You need to take rho s only. That is very important. You need to take rho s only. See, few students will take rho s. Okay, will take rho s and will do the calculation in rho s. But in some urgency, okay, but in some urgency in answering the question, go and check the option. Go and check the option. In option, out of 4 options, this option has row f. Okay, all the other 3 option has row s only. In some urgency, okay, in some urgency, there is a possibility of students to pick this option, but this is completely wrong. Why? Because density has to be density of the solid, but here you are taking density of the fluid, so this is wrong. This is a first common silly mistake. Even if you had attempted this paper, you would have also done this mistake. Okay, so this is the first common silly mistake which you will do. So what is the correct answer? It's going to be 1 by 18 rho s g d square, rho s g rho 1 by 18. This is anyways wrong, sign inverse. 1 by 18 rho s d square g by mu infinity. This is correct. Okay, this is correct. So the correct answer is tan inverse of 1 by 18 d square rho s g by mu into infinity. It is also a good question.